In this video, you will learn how to compute square roots, cube roots, and roots of the nth degree that have real and non-real answers. Example 1 involves square roots. So let's first compute the square root of 25. So we'll start out by hitting the second function key, and that operates this square root right here. So we'll hit this key, which happens to be the x squared key, and then we'll enter 25. And now we can go ahead and close the parenthesis. Hit enter for the answer. Now let's see if the answer changes if we don't use the closing parenthesis. So let's do the calculation. Second function, square root of 25, and let's go ahead and hit enter. And it does not make a difference. So you can go ahead and save a keystroke by not using the closing parenthesis for a single computation. So let's compute the square root of 144. Remember, we don't need the parenthesis to close the radicand. And let's just hit enter, and you get 12. The square root of 144 is 12. Let's clear the screen here. Let's see if there's any significance to the left-hand parenthesis for the square root option. So let's call up the square root. So there it automatically inputs this left-hand parenthesis. So let's go ahead and enter 4 plus 9 plus 3. And let's close the computation here. So we're saying to take the square root of the sum of these three numbers. And the sum of these three numbers happens to be 16. Then you take the square root of 16, and that should equal to 4. And indeed it is 4. So now let's do the same computation. So second function, square root, 4 plus 9 plus 3. Now let's see if it matters if you put the parenthesis on the end of the computation. Or what we're doing is we're closing the radicand. Let's see if it makes a difference. And the answer is 4. So it does not. So remember, to save a keystroke, you do not need to put a closing parenthesis on the end of the radicand. Basically what this calculator does is it recognizes that if there is a parenthesis on the left-hand side of the radicand, it's going to assume that everything after the left-hand parenthesis or the parenthesis in the beginning, everything after that is underneath the radicand. That's a very, very important thing for you to realize. That is, everything after the left-hand parenthesis is assumed to be under the radicand. So that's why it is not necessary to put a closing bracket on the end. Now, mathematically, in terms of mathematical notation, that's incorrect. The calculator recognizes its own notation differently than the correct mathematical notation. So let's go ahead and clear the screen. Now, just to prove that fact, let's do the same computation, and let's do a little bit of a twist to this. So let's again calculate the square root of 4 plus 9 plus 3. And we'll hit enter, and we know that's going to be 4. Let's say we want to take this particular computation and add that to 1. So we take the square root of 4 plus 9 plus 3, and we want to add that to 1. We definitely need to close the radicand here and add 1 to it. So what that's going to be is it's going to be this answer, which is 4, plus 1, which will be 5. And there we have it as 5. Now, if we did not use the closing parenthesis there, it would actually take all of these numbers, 4 plus 9 plus 3 plus 1, and then take the square root of that. So it would take the square root of 17. And let's just see what happens here. So if we take the square root of 4 plus 9 plus 3 plus 1, and we hit enter, it will be a completely different answer than 5. It'll be a little bit greater than 4. And there it is, 4.12. So again, that right-hand parenthesis closes the radicand, and any computation after the closing parenthesis will not be in the radicand. Okay? So let's clear the screen. Now let's go on to example number 2. Example 2 involves cube roots. So let's take the cube root of 27. So to do that, we're going to hit the math button first. And if you notice here, line number 4 says cube root. Now we can access this line by either hitting the number 4 on the keyboard, or we can scroll down using the arrow keys, which I'm doing now, and hit enter. And then enter 27. And recall, we don't need to use the closing parenthesis here, so we just need to hit enter. And we get 3. So let's go ahead and compute the cube root of a negative 27, because we can compute the cube root of negative numbers. So let's go to the math button. And now we'll just hit number 4. It's much easier to hit the number 4 instead of using the arrow keys. So we'll hit 4, enter negative 27, and again we don't have to close the radicand with the parenthesis. We just hit enter, and our answer is negative 3. Now let's clear the screen and move on to the next example. Example 3 involves roots greater than 3. So let's go ahead and first take the fifth root of 32. So what we need to do is go to the math key, and option number 5 is the nth root. Right here, this little x value in front of the root symbol allows us to put any root that you want here. You could put 2 to represent the square root, or you could put a 3 there to represent the cube root, but it's not necessary because we already have keys for that. Remember that this key here will represent the square root, and this right here represents the cube root. So let's go ahead and clear this screen, and let's say we're going to calculate the fifth root of 32. We need to hit the root first, and then the math button, and then line number 5, and then we're going to go ahead and put in 32. And hit enter to get your result. Now one thing I want you to notice here is there is no left-hand parenthesis that was automatically put in like it did when we used the square root or the cube root options. For some reason the nth root button leaves off the left-hand parenthesis. So this is going to be important if you recall what the left-hand parenthesis did in the previous examples. So let's just do one more quick calculation. Let's go ahead and compute the ninth root of negative 1,000. So we need to hit the ninth root, then the math button, then number 5, and then negative 1,000. And we hit enter to get our result. Now notice here we are actually in the floating point decimal mode, and here's our answer to, let's see, 1, 2, 3, 4, 5, 6, 7, 8 decimal places. Let's say we want our answer only rounded to 3 decimal places. What we would do is we would go to the mode button and then bring it down to the float mode and then over to the fixed mode on number 3, and then hit enter, and then we would clear out of this screen, and then we can hit enter again, and now it gives us our answer rounded to 3 decimal places, which is right here. Okay? So let's go ahead and clear the screen for another example. So remember, we computed the fifth root of 32, and let's do that again. So the fifth root, the math button, and then line number 5, and then 32. Let's hit enter. And we get 2. So now let's go ahead and Compute the fifth root, hit the math button, then line number 5 of 32. So what I'm going to do is put a left-hand parenthesis and then enter 30 plus 2. Now if you remember, what this will do is the left-hand parenthesis in front of this operation assumes that there is automatically going to be a closing parenthesis on the end. It's assuming that all this is under the radicand. So we should get the same result if we hit enter, because it's going to be the fifth root of 30 plus 2, which is the fifth root of 32, which should equal 2. So hitting enter, we get 2. Now, let's do one more calculation here as a comparison. So we're going to take the fifth root, the math button, then line number 5, and we're going to hit the fifth root of 32, and then plus 1. Now, what this is doing is it's computing the fifth root of 32, getting that answer, which we know is 2, and then adding it to 1, which is going to be 3. So, if we hit enter here, it should be 3. So again, these three examples illustrate the importance of the left-hand parenthesis and what it actually tells you. And it tells you that everything in front of this left-hand parenthesis is inside the radicand. So let's go ahead and clear the screen, and we'll go on to the next example. For the last example, let's compute a root that has a non-real answer. So what we need to do is, let's go into the mode key, and remember, right now we're in the real mode. So let's change it to the complex mode, right here where it says a plus bi. So we move the cursor down, and move it to the right, and then we select enter. And then to get out of this screen here, the mode screen, we can either go second function quit, or just simply hit the clear key. So we will do that. Hit the clear key, and let's compute the square root of negative 16. So let's go second function, and hit that key, and then negative 16, and then close the parenthesis, and select enter. So it gives us our answer as a complex number, a plus bi, where a is the real part and b is the imaginary part. Of course, in this case, a is equal to 0, and the imaginary part is 4i. So if we took the square root, let's say, of negative 1, so second function, and then the square root of negative 1, we should just get I. So we select enter, and there we have it. Now, let's go back to the mode key, and go back down, and let's put it in the real mode. Select enter, and then let's clear the screen. Now let's see what would happen if we tried to compute the square root of negative 16 in the real mode. So let's go second function, and then the root key, and let's enter in negative 16 again, close the parenthesis, and select enter. See, it gives us an error. It says non-real answer. Okay? So I just wanted you to be aware of how answers are displayed differently in the real and complex modes. One final thing that I really want to emphasize here is this point. If we go to second function and then the root key, anytime you see a square root, a cube root, or the nth root, and you have a left-hand parenthesis to start the computation inside the radicand, it is assumed that everything after the parenthesis will be inside the radicand. If the parenthesis is not there, you can only take the root of a single value. Remember, the only time that the parenthesis is not automatically put there is for the nth root. So if we put the fifth root and then select math, and we hit number 5 to get that nth root, notice that the parenthesis is not automatically put in for you. So you would have to manually put it in, and then everything after that parenthesis will be assumed to be in the radicand. So we can put something crazy in here like 4 minus 3 squared plus 12 minus 2 times 8 plus 14. This whole computation here is going to be inside the radicand, and if we hit enter, that will be the correct answer. Okay? Now, if you want to take out the leading parenthesis right here and do the computation, we're going to get a different answer. So let's do that. We're going to take the fifth root, hit the math button, number 5, and we're going to put in 4 minus 3 squared plus 12 minus 2 times 8 plus 14. Now remember what this is going to do, because there is no leading parenthesis here, what's going to be computed is just the fifth root of 4. Subtract 3 squared plus 12 minus 2 times 8 plus 14. Note that the order of operations will be used for this computation. So we're definitely going to get a different answer than what we have right here. So let's select enter, and there's our result. Completely different than our answer above. This concludes the video on computations of various roots.